Okay, so I'm...
Emily, I hear you. Hang on, I'm on a different screen. Can you see me, or I don't know how this works.
I can see you.
You can. Oh, okay. Hang on. I don't know how to get from this window. There. Okay. Hi, Emily. Were you
Hi.
get this through the email?
Excuse me?
You got this link through email, right?
Yes, I did.
Okay. Everybody else is saying they didn't get their email. So
it's because it's on the it's on a different section. Does that make sense? Okay.
Oh,
Dean's on.
Yep, got him. Hello, Jordan. Your camera is off. Is that is fine, Jordan? If that's what it needs to be, but you know, try to turn the camera on if you're able. So now we just need one more Emily. And let's just hope she joins in a second. All right, so I'm gonna really quickly finish what I was doing on the other screen.
Okay.
And that was, I'm making sure that I can see. I wanted to check your test just so that I remember if I gave you terms on this test or not. So I was trying to do that. Joel is awake again. I'm not a happy mama. Sorry.
It's okay.
He is being very difficult right now. So, yeah. All right, let me just look. Oh no, come on. Hang on. All right, and also you guys will see when Emily Carr pops up. Tell me when she pops up as well.
Okay.
And maybe somebody can text her for me and just ask if she's having trouble with the link, because I want to see that. All right, so there's 1, 2, 3, 4. So about 5 multiple choice. There's some modified true false. Let's see. There's some more multiple choice. There's some naming. There's some writing formulas. And then on the other page, there's going to be some writing, drawing, Lewis directions. Okay, so now I remember what's on this test, which was, slightly important. And let me see if everybody's back here. Oh, no, just Emily. Ah, they left.
They left?
What happened?
Emily Carr is coming, or is getting on.
Okay. What about Jordan?
Well, Sharon?
Yeah, they're figuring it out right now.
All right. Is that your mama here? No, I see Jordan's back on, but he can't see us, I don't think. Yes, we are here. Can't see. All right. Emily, was that your mom I was hearing there? Oh, no, they left again. What? I'm so confused. Emily, are you still here? All right, I see Emily Carr. Hello?
Yeah. Do you hear me?
I can hear you. Can't see you, but I can hear you.
Hold on.
Here you go, Jordan. Wait, what's going on? Are you guys still here? Let's see. I don't know why they keep saying there is an error. Got it. I don't know. Do you have a good internet connection right now? I see you again, Emily. Hi.
The camera's so loose. Maybe we should just set it down. And
There you go.
All right, so Emily, the camera froze. No, I can see you on camera now. Emily,
Breathing Emily's really.
All right, so both Emily's here, and we're having trouble with Jordan leave or his internet or something.
Okay, mine's better now. It's not frozen.
Yeah, you're not frozen anymore.
hi.
I don't know what's wrong with Jordan. I'm so sorry.
Emily Carr, are you going to the Wilds?
What?
Are you going to the Wilds?
Yay! There's
I
Jordan.
don't think so.
Okay.
Hi. All right, we have all 3 of you. Let's pray to get started. Because, we don't want to have anybody get lost again. So let's go ahead and pray that our technology will hold and that we will be able to have this full lesson. Any other prayer requests?
No.
Okay. Dear
Nope.
Heavenly Father, I thank you for today, and I do pray that you just help Joel to fall asleep and get his nap, and I pray also that you'd help this video lesson to not only be effective, but also that our cameras and everything would be working right so that we can all be able to hear everything that we need and see everything that we need. I pray this in Jesus' name. Amen.
Mom.
I'm still sick. Sorry, guys. I have to deal with a stuffy nose teacher. So, this is our official review for the test today. I realized that I can grade the things online for quiz chapter 8, but I can't grade the paper part where you did your Lewis structures until Thursday. So what I'm going to do while you're starting your lab is I'm going to grade that paper part and try to give it back to you before you leave, because I want you to be able to see if you did it right or not before your test, you know?
Mm-hmm.
So that's the point that I'm going to make sure that I'm able to give those back to you graded before you leave on Thursday, okay?
Okay.
Our test is still going to be good to be on Tuesday, and what will happen with that is you can take that test home, and, you know, because Tuesdays we don't meet anymore. So what I'll do is I'll give the paper portions to you on Thursday to take home. You know, your parents can have that so that it's not like an issue. You won't see it until Tuesday. And I will also have this chat open on Tuesday so that if you have any questions, you can ask me. But if you guys, I mean, I don't know if you're all going to take the test at the same time. So if you take the test early, that's fine. And if you take it early and don't have any questions, that's fine. If not, I will be here just in case, you know, so that you have this as an option. But if that does help you, I might not do it that way anymore, but that's what I thought would be helpful, is to have access to be able to ask me questions. Other than that, I did just remind myself of what's on the test. You definitely have, for the paper part, you're going to have to draw Lewis structures, label the shape, and the angle. All right, so just like we're doing on our lab tomorrow or Thursday, you're going to do the same thing where you draw a Lewis structure, you label the shape, and you label the angle. All three of those things. That's a big part of your test. Then you're going to have the online part, and that part is only going to be a couple multiple choice terms, you know, so there's some terms throughout this chapter. And then it's going to have some modified true false with terms again. And then it's going to have naming, like naming covalent bonds, so, and acids. So you have to name the covalent bond and the acid both. And with acids, remember, you're going to have binary acids as well as oxyacids. And then you're going to have the reverse of that, where I give you a name and you have to write the formula. Okay, so that's what your test looks like. And so today, what we're going to do is just practice a bunch of stuff to help you get ready for that. All right, so what I'm going to do is actually just like start off with, I think, the chapter review and start going through some questions and having you guys actually practice the things that we're going to be doing. Does that sound good?
Yes.
Yep.
Okay, so we're going to start on page 274. That's where your chapter review starts. And the thing that I think would be very helpful to start with is the, not the terms, because you guys can obviously just go back through and look at your terms on your own. But I'm going to start with the practicing naming and practicing writing formulas. And then I'm going to practice writing Lewis structures and telling the shape of the angle of those. And if we have time at the end of this hour, we will also cover the terms. But otherwise, you're responsible to do the terms on your own, okay? So we're going to start on page 274. And notice how it's going to say on 92, number 92, you're given a formula and you are expected to write the name. Those are all what? Notice they start with H. So what is special about these?
Acids?
They are all acids. So remember, look at it if it's a binary acid or if it's oxyacid. And if it's an oxyacid, remember that ite becomes us and H becomes ick. All right? And you don't use hydro for those, just for binary. So go through and try to name those 4 things right now. Go ahead and write them down, get your answers, and type them in. Don't type them one at a time. Write down all 4 and type all 4 at the same time so that we're not having like one of you have the answer before you're ready. Okay, so write them all 4 down and then type them in.
What numbers on the page?
92. On page 274, it's number 92. It's a table.
I see, yeah, okay. What?
Do you see the table now?
Yeah.
No, Jordan, don't type them in quickly. Type them all at the same time. All 4.
Someone was not listening.
Shame, shame, shame.
You should though.
Yeah. HClO2. Uric acid. No, he's not right.
Wait,
Because ClO2 is not chlorate.
it's chloride.
Chlorite. So it becomes
Chlorous acid.
chlorous acid. So your ending was wrong. Look, because this is still a review, I would suggest while you're practicing, hang on, I'm going to tell you the page that the polys are on. Have your finger in your book on page 221. Do it first, and then go back and check yourself and see if you were right. Okay? But have that page, and before you type your answers in here, actually check to see if you're right. Uh-oh. I lost you guys for a second. Still have Joel crying. He's like refusing to go to sleep today. I've spent over 40 minutes trying to get him to go to sleep. I've done it nicely. And then I got to where I was just like, okay, you're laying down. I'm going to pop your bottom if you get up. You're laying down. I'm going to pop your bottom if you get up. And he finally fell asleep. And now he's back up.
Whoa.
All right, do you guys have all four?
Yes.
Mhm.
I'm typing right now.
Okay, so let's, instead of typing them, because this one,
I'm
we can
close.
just say them. So we're going to start with the fact that we already had 92 on the board, and remember that that was HClO2, which was not chloric acid, it's chlorous acid. So what was H3PO4? We'll have to be Mongol.
And the Mongol added hypophosphorus acid. I was confused with this one.
Good, phosphorus acid, but remember you have to change the phosphorus into what?
Phosphorate.
Okay, so that's phosphate. So you'd go to, instead of phosphate, you're going to say,
8 turns to ick,
yes.
and I turns to us. So it's, what do I have? Phosphorus?
You have phosphate.
Okay.
So it's
Phosphorus.
phosphoric acid. Good. So that is phosphoric acid. Next, Emily Carr, H2SE. Go ahead.
That hydro begins with that, right?
Yes.
Hydro, and then the root, and then I. So is it like selenide?
Selenic. Here, let me type this. All right, so I'm going to type them all in as they are, and you guys can check yours because it's a little easier this way. So the first one should be CHLOROUS acid. The second, oh, when I push enter, this doesn't let me do enter the way I want to do the enter, so it'll just pop up each one of these as I type them. Sorry about that. So the next one. Phosphoric acid. Then we have our hydro.
Why does it keep on switching to Jordan and then back?
Why does it keep doing what?
Never mind. Mike told me.
Okay. Oops, I'm sorry. I typed that in. I spelled that wrong. Hydro, S-E-L-E. There's this first I is supposed to be an E. Selenic. That's an S-E-L-E-N-I-C. So that's selenic. Hydroselenic acid. And then
On a test, would we get points off of spelling things incorrectly?
depends.
Yeah.
Because we can't exactly memorize all of the atoms on the entire.
Well, we have the periodic table.
We'll have it during the test.
What?
We'll have the periodic table during the test.
Yes, you're allowed to use your periodic tables on this test. So the periodic table has the elements spelled. So for instance, if you were doing selenic acid, like hydroselenic acid, I would expect you to know how to spell selenium. And then you would just have to change the ending to IC instead of the ending for selenium. Does that make sense?
But like with the phosphoric acid, I had put down phosphoric acid, but I get points off for that.
I'm going to say the ones that I expect you to know that have weird endings. Sulfur, because instead of saying like when it's H2SO4, like, oops, hang on. And it's this, H2SO4, that's actually sulfuric acid, not sulfuric. Like you actually keep the and I stress that to you guys that with sulfur, when we do things with sulfur, like hydrosulfuric acid and sulfuric acid and sulfurous acid, it keeps the UR, right? So I expect you to know that because we've covered it. Most of them, most of them are not actually hard to tell. They usually just have an easy ending that's a root that's traded out, and so it's not actually tricky. The only thing with phosphoric is I think that the sound as well. They didn't want to say phosphic acid because it sounds like a different element. Phosphoric acid versus phosphic, it doesn't sound like phosphorus. So I think the is included in those two elements like sulfur and the phosphorus is because it doesn't sound like the same element. Okay, so no, I would probably not take off points for that, but there's a couple that are really distinct. Phosphorus and sulfur, because we've covered them so many times, those are pretty distinct, and I want you to remember that, okay? So I'm not going to be like a stickler on ones that aren't common, but, you know, we've covered a couple of these enough times that I think you should kind of remember the nuances, okay? All right, and you can always, hey, that's why I'll be online. You can always shoot over and go, hey, would this be phosphic acid or phosphoric acid? And I'd be able to answer that because it's not like, I know that you know it, you're just asking about the spelling. And so in my opinion, if you have a question like that, you're allowed to ask and I'll answer it before you type it in, okay? So those type of things, just, that's why I'll be online. All right, so are we ready to go on, guys?
Yes.
All right, so now we're going to name, instead of acids, which remember your nuances with acids about the binary and the poly. Did you guys do okay on these?
Which ones?
The ones we just did. Did you do okay? Good.
I missed
You missed what?
missed a couple.
All right, so look, you need to go back and review those rules. They're on section 2. Naming is really important, so you want to make sure you know how to name. We also did a couple worksheets on those, so make sure you go back and before Tuesday, practice that. Now I can't, like, it's not going to be something that I can do for you. It's just you have to do it a million times before it gets second nature. So I would take that worksheet and I would rework through that worksheet that had 100 questions and try to really practice and see if you got it. Okay, so we're going to go on to just naming molecules, which are not acids. In this case, these are all just covalent. We're using the names. Now look, even though they say SO3, which is a poly, don't name it like the poly. Actually put in with the naming, like use the naming rules. I want you to use your prefixes like di and tri and tetra. I want you to use those. Actually name these with those in mind, not naming it as sulfate or sulfite. Okay? Go through and do those 4, and then we'll put the answers up in a second.
93 to 96?
93, just 93.
Okay.
We'll do them one at a time.
Oh, I forgot there's, I didn't see that. There's 4 on
All right, so these should have been really easy. Are you guys ready?
Somewhat.
One sec.
Do we type your name or just say the number?
All right. Ouch. Sorry, I just hit my elbow. So here's how we're going to do this one. I'm going to have you say these ones. So SEO2, Jordan, how did you name that?
SE, wait.
I'm sorry, I'm reading the wrong ones. NF3, how did you name
Oh,
that?
yeah. Nitrogen trifluoride.
Good. B, NO. Emily, first, Emily Mongold.
I put
Thing
nitrogen
one.
Emily, thing one.
oxide.
Oh, there's a prefix you need. What do you do to say that you have one?
Mono.
Monoxide.
Now, watch this. Remember the rule about dropping the double vowel? So instead of writing MONOOXIDE, that's wrong. Monoxide is redundant. You just go MONOXIDE, monoxide. That's how you would say it instead.
Okay, so nitrogen oxide.
There you go. All right. Emily Carr, or thing two, go ahead and do the next one, which was SO3.
Sulfur trioxide.
Good. And then the last one, Jordan, go ahead. The SI.
Oh, that was the one that I haven't written yet because you caught me off guard.
That's okay. I mean, just look at it. SIF4.
Silicon tetrafluoride.
That's it. You guys got it. All right. So next, number 94 is going to have some of these that are not going to be nice because they have prefixes on the first one. Remember, when we only have one, we don't have to name the first one. But when we have two on the first one or three on the first one, we do need to include that prefix on the first one. So go ahead and name number 94, A, B, C, and D.
Okay.
I am going to go rock Joel, spank his butt, and put him back down. Because he's probably standing up going, ah, right now. And he needs to be laying down. So I'll give you a second to work on this while I go and take care of him.
Have fun.
Right for me.
Are the first two almost the same
Yeah, except that the
prefix?
Best teacher, not me.
prefixes will be different on the oxide.
Stevie, are you going to Wilds this year?
Huh?
What?
What'd you say? I thought you said something.
Are you going to the Wilds this year?
I don't know. I might go on the mission trip. I'm not sure.
You should go to the Wilds. That'd be so fun. So fun. So the mission trip is in 2 years ago, or not 2 years, it's 2019.
Emily?
Okay. Can you guys hear him? He's not a happy baby.
Oh,
All right. Did you guys get them finished?
yes.
Almost.
All right. So I'll give you like 2 seconds. All right. So we're going to start with 94A. And if you're not finished, that's fine. Keep working on the other ones, but also check your work. And Emily Mungold, thing one, we're going to start with you.
Have selenium dioxide.
Good. Then Emily Carr, thing two.
Selenium trioxide.
Good. And then Jordan, you get the first hard one.
The nitrogen tetrafluoride.
Good. And I would say di instead of D, but that's fine. It doesn't matter as long as you type it in right. So now the next one, let's go Emily Mungold.
Tetrasulfide and tetranitride. Is that right?
Close. Do you put suffixes on the first word?
Hmm.
No. So you don't need you just need to say,
Sulfur tetranitride.
all right, put the prefix in the front still. So you go tetrasulfur
Tetrasulfide.
tetranitride.
Oh, okay.
The only thing that you had said the first time was you said tetrasulfide, tetranitride. You didn't need the "ide" on the first word. Only on the second word do you need the "ide." That's
Okay.
it. Always just on the second word. But when you have a prefix on the first word, you just put the prefix. You don't add the "ide."
Okay, I didn't know that.
"Ide" only goes on the second word, ever. Only ever. All right, how do you guys feel with that?
Easy.
All right, good. So even if it's easy, you're doing well for that section on the test. If it's hard, like the acids, you guys need some more practice. So you need to take and go, oh, that's where I need to study. Okay, so this is to help you go, these are the areas that I really need to focus on. So some of you might need to go back with the acids, but I think that you got, for the most part, the naming of the regular stuff, you got that down. So what we're going to do now is the reverse. I'm going to give you a name, and you're going to write the formula. Okay, so let's look at number 95. And I would like you to write the formulas for these 4 things. All right? And it's mixed review because you have some acids. So remember that, pay attention when it's an acid. This should be easy. This is fun.
That's easy. Just see.
All right, let's do this. Do number 95 and 96. I am going to go and try to calm him down, make him go to sleep, and I will be back in like 2 minutes instead of like just 1.
Okay.
But when I get back, we should be able to go through all 4 of these or all 8 of these at the same time. Okay?
Okay.
All right.
Emily.
Yeah.
We will have CEF this week, right?
Yes, we're having CEF this week.
Okay.
And
I was wondering about that.
Yeah.
do you know how like?
Yeah.
Do you think it'd be difficult for your family to drop me off at home after CEF?
That shouldn't be a problem. You're
If,
on.
if,
Yeah.
if you can't, I'm pretty sure my mom could pick me up or someone, but
Yeah, you're on the way for us. That should be a problem.
I kind of miss CEF. It's been like
I
a
do
really
too.
long time.
I'm excited to get back in the swing of things.
Mhm.
I'm excited for this year to be over.
Why?
School year.
I'm not.
You're not?
No.
That's nice.
That's one thing I'll still have to do school during the summer. I just won't be around people as much.
Oh yeah,
I'll
that
be
would.
doing it at home.
Yeah, that stinks.
Yeah, it does.
Hydrobromic acid. H.
Well, I know H is in there. I can tell you that.
Bromide is BrO3 negative.
No, that's not for you. I know. Say hi. The triumphant little.
Hi.
Hi.
You.
Um,
Oh,
All right.
so cute.
Go play, you little monster. I'm just not okay with it. Whatever. Hi guys. Being a mommy's hard. You don't know if you make the right choices or not sometimes. Let's go ahead and do the formulas. So, did you guys have time to do both?
Yes.
I'm not done with 96.
You're not done with 96?
Mm-mm.
Okay, so how about you, Jordan? Are you finished yet?
I'm finished with 96. Yes.
Okay, good. So,
I mean, no, not 96. No. 95. Sorry. Whew.
Okay. So let's go over 95 first, and then you guys can finish 96 in a second. So let's start with the formula for sulfur difluoride, and we'll go Emily Carr, you first.
That was SF2.
Good. Then we have silicon tetrachloride. Jordan.
SiCl4.
Good. Now, let me stress to you guys, when you're doing elements that have more than one letter, capitalize the first, leave the second lowercase, like such. So this was SiCl4. That's what it would look like when you type it in. SiCl4. And yes, that is an L, not a capital I. Which I know was a struggle earlier in the year.
I see it as an L now. When I look at it, I'm used to that.
Good. All right. So now we have carbon tetrafluoride, and it's Emily, your turn. Emily, thing one.
I said C, capital F4.
Perfect. And then last but not least, H2, or sulfurous acid. Sulfurous acid. So what did you get?
I had put down HSO3. So there's a 2 after the H.
This is why. When you do an acid, you actually have to balance the charges, just like when you did ionic things. So let me see if I have pen. I have a Sharpie, and I have some paper. Hydrogen, like you would write down to start when you do when you take a name and you write a formula from it, you write your elements. So we have hydrogen and we have SO3, right? Those two things. Then you have to check the charges. What's hydrogen's charge?
+1.
+1. What's SO3's charge?
2 negative.
2 negative. Crisscross those charges and you'll get your subscripts. So how many of the hydrogens are you supposed to have?
2.
And how many of the SO3s?
1.
There you go. That's why it's H2SO3. Everyone on the same page?
Yep.
Does that help? Because this actually is true. Let's say that we had hydrocarbonic acid. What are my elements?
Hydrogen and carbon.
Hydrogen and carbon. Now you have to check the charges. What's hydrogen's charge?
+1.
+1. What's carbon's?
+4.
Not plus, minus, because we always want a plus and a minus. So crisscross, and you're going to end up with what?
H4C.
Yes. You see how you're going to have to do this every time you name an acid. Every time you have to check the charges.
Unless they both have prefix.
If they both have one. If you're doing names for not acids, but for normal things, like when we did the name for silicon dioxide, obviously that's telling you we have, well, we haven't done that yet, but I'll give it to you. We have 1 silicon and we have 2 oxygens, right?
Mm-hmm.
But for acids, they don't give you those prefixes. So every time, Emily, every time you name an acid or write a formula for an acid, you're always going to check the charges.
Okay.
All right. And sometimes there's a 1-to-1 ratio. Let's say you have HCl. Name that for me. HCl. What would that name be?
Hydrogen, chlorine.
Chloric acid.
Hydrogen and chlorine. So it'd be hydrochloric.
Hydrochloric acid.
Hydrochloric acid.
Yeah.
All right. So now check the charges. What's hydrogen's charge?
+1.
And this one is?
I don't know.
In group 17. If it's in group 17, it's going to be a negative.
7.
Negative.
-1.
-1. So we're going to have 1 of each. So we just write this as HCl.
Oh, then I forgot how to do that.
Yeah, that makes a lot of sense.
Emily, you forgot how to do what?
Figure the charge. I remember now, but I got messed up in so long.
Okay, yeah, you have to check the group that it's in. Remember that we have group 1 is +1, group 2 is +2, group 13 is +3, group 14 could be a +4 or a -4, depending on if it's with a positive or a negative.
And then 5 is negative.
15 is -3, then 16 is -2, 17 is -1. Because they're gaining electrons to become 8 valence electrons. The 5 will gain 3 electrons, which is why it's -3. 6 will gain 2 electrons, which is why it's a -2. 7 will gain 1 electron, which is why it's a -1. Very good? Okay, good review on that. Now 96, you guys. If you haven't done it already, we're going to make you do it on the fly. Ready? Jordan, start with the B, because I already gave you silicon dioxide, which was SiO2. All right, so let's try bromous acid.
HBr3.
You have to remember the other element. If it was just HBr, it would be hydrobromic. So what's with the bromine? What's
Oxygen?
with the bromine in the 3? Oxygen. Good. So you have hydrogen and you have bromine, and you have to have the oxygen. But this is bromous. So remember, it's not bromate, which would be BrO3. It's bromite, which would be BrO2. So this is it.
Technically, we never memorized that.
Oh.
Technically, we never memorized that. It shouldn't be on the test.
Technically, you had a Poly 1 and a Poly 2 quiz, which I told you would be used for the rest of the year, which will be on the test. And I know that it'll be on the rest of the year. Every test and every quiz will have a Poly on it.
Yeah, but bromite, I don't think was on either of the poly quizzes. That's what I'm saying. Bromite was not.
Doesn't have to be on the quiz to be on the list. Which chart did I ask you to memorize? The whole chart. Out of 26, I only quizzed you over 20. So there's 6 of them that I obviously did not have on the quiz, but that are still important to know.
I don't think we memorized bromite. I'm looking.
Yeah, you should have. Hang on.
It's not on the
Oh, you are right, Emily.
I told you.
It's not on the list, but you still should have been able to figure it out. But you're right. It wasn't on the list. I apologize. I love you, and I apologize. Thank you for being so diligent and having memorized it so well that you were able to pick out one that wasn't actually on the list. I just actually thought it was just on the list. I'm proud of you. This is teacher love. I'm proud of you. Like, really proud. That was really good. All right. So that wouldn't be on the test because I didn't make you memorize it. So you're right. I would only give you polys you've memorized. All better? All right. I'm eating my humble pie. Tastes good. All right, so now we have chlorine trifluoride, and that's you, Emily Mungold.
Chlorine trifluoride, ClF3.
ClF3 is correct. All right, and then we have hydrobromic acid, Emily Mungold, or Emily Carr.
I think that was HBr.
That is just HBr, because the hydrogen is +1, bromine is a -1. It's just HBr. And notice, Jordan, this is actually really helpful. No, you're not gonna know. If you're gonna be out here, you're gonna go play. This is a crappy baby. It's what we got to deal with right now. All right, so here's what we're gonna do. And Jordan, I was trying to point out to you. that that you have the difference between. I'm sorry, guys.
It's good.
The difference between HBrO2, which was bromous acid, and hydrobromic acid. Just wanted to point that out. That's all. All right, going on. So now we really need to practice drawing Lewis structures, naming angles, and naming shapes. So what I'm going to have you do is, even though the book's not going to ask you to do all of those at the same time, I am going to ask you to do all of them. So what we're going to do is start on 102. Oh, let's start with 101. Please draw the resonance structure, and I'm only going to look for one shape. Resonance structure for CO3 with a 2 negative charge. You want to bite? You want to bite? All right, come here, baby. Here. Take a bite. Go and eat. All right. Do you guys remember how to count up everything? How many electrons from carbon?
4.
Plus how many elements from electrons from oxygen.
6 times 3.
6 times 3, so plus 18. That's going to be 22. What happens with our -2? You add it because we have to gain electrons. So we have 24 electrons. And then what do?
Divide by 2.
Divide that by 2. We have 12 pairs. All right, so what's our center?
Is there what?
Carbon.
Carbon is the center. Then you connect what?
Oxygen. The 2 oxygens.
3.
There's 3 of them, though.
Oh, 3 oxygens. Sorry.
Yes. No, you're fine. All right, so far we look like this, and we have to subtract 3 from our 12. So what are we left with?
9.
9. So where are we going to try to put those first?
Around the oxygens.
All the oxygens, because remember, carbon's such a good host, it's going to fill up its friends first. So we're going to put 1, 2, 3 pairs on each oxygen. Notice once you do that, you've used all 9 of your electrons. Good. Now, after this step is where you need to pay attention. You check the center, and is the center full?
No, so it needs to
It needs to shift to make a what?
double bond.
To make a double bond. But look, here's where it's different. And I haven't, because I have a Sharpie, I didn't draw my third pair because I'm going to do resonance. So just bear with me, pretend that there's a third pair here, here, and here. So is it okay to share with this one and do a double bond here?
Yes.
Is it okay to share with this one and do a double bond here?
Yes.
Is it okay to do a double bond here?
Yeah.
What's going to make it want one over the other? Like, what makes this oxygen better than this one?
Nothing.
Nothing. That's resonance. And when you see this on your test, because I guarantee you're going to have a resonance one, because why would I teach you and not test you on it? So when you see this and you get to this point where you go, I need a shift and make a double bond, but it could happen at any of the options. That's when you do resonance and you erase. And in this case, I didn't draw, so I don't have to erase. You erase one of the bonds and you put it as dot, dot, dot along the line. See?
Uh-huh.
And you do that on all 3 of them because they all could be used. So you're showing the double bond with all 3. That's how you do this.
Okay, so there's no extra then after that?
So there's no extra. We just do like that.
Okay.
That's how you show your resonance, okay? Good. Now there's one last thing. What do we do to things with charges?
Put them in parentheses and add the charge.
Good. We put them. Here you go. Have another bite. Just throw food at him. He'll be okay.
So, would you mind if we went over paper sections of the test and the quiz and touched them up?
Would I mind if you did what?
Because I have the paper quiz left, and I'm like, I probably got this wrong on some of them.
No, that's cheating. You are not allowed to go backwards and fix your tests or your quizzes afterwards. I'm sorry. I love you. That's not allowed. So do not, that's not okay. So don't do that. That would be very bad. Thank you for asking, though. All right, so here's the next thing. You're going to draw the Lewis structures, and look, these do not obey the octet rule, because remember, we could have sub-octets or we could have expanded octets. What happens when you have a sub-octet?
Take a bond.
The center will have less than less than.
So it has to have double bond or triple.
In these cases, they can't. Like boron, if boron is bonded with something, it could have 6 and it's not going to do a double bond, even if it had like fluorine instead of hydrogen, and it could do a double bond, it won't. In nature, it just doesn't. So boron will be full with 6. That's why it tries to become a coordinate covalent bond, a good term to know. You know, one of those multiple choice types of things. The coordinate covalent bond was where boron shared with nitrogen because, you know, it didn't give any of the electrons, it just took nitrogens. Remember that? The mooch? All right, so sometimes that can happen, and it will in this. There will be some sub-octets. Then you could have expanded octets, which means that they have more than 8, and that's okay if it's in row 3 or below on your periodic table. So I'm going to have you do A, B, and C. We're going to skip D. Just A, B, C. Please draw those 3 right now for number 102.
102.
102.
What?
You're doing 102, A, B, and C. Now,
Page.
on page 274. I'm going to go let my cat in. Nope, 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 nope. Hey.
Hi.
He climbed up, sorry. Oh, he wants to say hi again. Oh, you want a bite? Here. There you go. Yeah. Yummy. Pop-Tarts are good. Full of sugar. Yay. Do what you gotta do sometimes. Sorry. All right. If you guys beat me, I'm going to be very impressed.
Done? No, just kidding.
Okay.
I'm doing them all at the same time.
Yeah, you're supposed to. I'm writing out all 3 of them at the same time right now too. Yeah, all 3, and we're gonna check all 3 at the same time.
Oh, I did 4.
Oh, did you do B, E, H too?
Yes.
I mean, that's fine. It's really easy, so that's okay.
Yeah. Finished.
I just have to add my dots now.
Okay, so I have all 3 done as well, and here's what I'd like you to do as well, because we're not only going to have to draw the Lewis structure on the test, we're going to have to name the shape and the angle. So with all 3 of these, and or 4 if you did all 4, go through and tell me the shape and the angle as well. So remember, count from your center and see how many single or lone pairs. So single bonds and how many lone pairs. And by the way, you know, that's, yeah, anyways, just start there. Sorry, guys. Yeah. Geiger. Okay. Gentle. Gentle. Be gentle with the puppy. All right, please let me know that you are done. Jordan, you said you were done with all 4, and you've named the shape and the angle?
I have not named the shape yet.
Okay, go through and do that, and then let me know, ladies, when you're done as well, so that we can go on.
I'm just naming them and I'll be done.
Okay.
Why? I don't know.
Okay. I'm done.
All right. We're gonna wait for the other two.
I don't have the angles yet, so I need to check that.
All right. Are we ready? Too much sun, Emily. Yeah, the sun's like blinding.
That's not good. There you go.
All right, so I'm going to show you guys my answer for the first one. PCl5. Ready? This top one right here. Check your answer. You have phosphorus in the center. You have 5 chlorines around the outside, and each of the chlorines is full. This is an expanded octet called a or an. Is it a sub or an sorry, I said expanded octet, didn't I? It's an expanded octet. That was what I was asking. All right, so now, because we have 5 single bonds off the center, what shape is this?
Trigonal bipyramidal.
Trigonal bipyramidal. Remember that you'd have one on the top, 1 on the bottom, and 3 in the center, like right there. What are the angles? Because this one is the only one that has 2 angles. What's the angle for the triangle in the center?
90.
120. Good. What's the angle between the top and the bottom?
90.
90. So the angles are 120 and 90. All right, good. Now we're going to do BF3 right here. All right. So notice boron is in the center and fluorines are on the outside. Note here, even though I would think this would be resonance, it doesn't. It actually does not do resonance. It stays like this because boron is one of those elements that can be happy with 6, and resonance is more energy or more work for an atom to do, a molecule. So because it takes more energy to do that, it's not going to do that. It's just going to stay, and boron is just going to be happy being gypped. Okay? That is an exception that you need to know. So because of this, we just have 3 single bonds on the center. What do you call a shape when it has 3 single bonds on the center?
Trigonal planar.
Trigonal planar, because it's a triangle and it's flat. Good. What's the
120
angle?
degrees.
120. You guys got it. All right, now let's look at the last one here. This was ClF5. Notice how this are different. This one was a 7 times 1, 2, 3, 4, 5, 6. 7 times 6 when you did this math. Whereas this one was
I don't think
7 times 5 and then plus 5. So the chlorine is also 7. So that means you have an extra pair. See? And so the extra pair ends up going in the center. Anytime you have extra electrons, put them on the center. Anytime. Always it goes on the center. Because just like the center could be gypped, if it, being a good host, it might lose out like boron did. Well, the center is also, because it was a good host, it might get the extras if there ever is extra. So anything extra goes on the center. All right, so now look, this is different from this one, which was trigonal bipyramidal, because this one has 5 single bonds and a lone pair. So what do we call this instead of a trigonal bipyramidal?
Octahedral.
Octahedral. Good. And what's the angle on an octahedral?
9 degrees.
9 degrees. Now, I want a disclaimer right now. Your lab is more specific than that. You notice that your lab has more shapes than your book? And when we do the lab, we will name them based on more specific. Like they'll have a square in the center for when you have, instead of doing octahedral for things like this, they would call it something else. We are not going to do that with our test. We're going to stick to the easier route of if it's got more than 5 things on it, just call it octahedral because I want to make your life easier. Okay? So that's why we're going to just, even though we know that there is a more specific name for something like that, we're going to just call it octahedral and be happy and move on. Everyone good?
Yes.
All right.
Got it.
What's the angle on an octahedral?
90 degrees.
90 degrees.
90.
I may have already said that, but I couldn't remember, so I wanted to cover it just in case. All right, now let me show you the BHE2, or BH2. This is BH2 if you ended up.
Linear.
What's the shape?
Linear.
Linear, good. And what's the angle?
180 degrees.
180 because it's a straight line. It's perfect. All right, guys. Do you want to practice more Lewis structure things, or do you feel comfortable with this concept?
I feel
I'm good. Are you guys good?
I'm good.
Okay, so what I'd like to do is look through. I think that what we need to do next is practice some of the stuff from section 5, like electronegativity, and telling me which atom is more electronegative. And remember, I will give you the values that are on the table, so you'll be able to find them easily. So let's go all the way over to there, 118. It's on page 275. Number 118 is very similar to how I'm going to ask this on the test. So focus here. Notice how it asks, for each bond listed, tell which atom is more negatively charged. So you're going to, now you could, with this one, you could actually just go by the trend and see.
Which number? Page
Yeah.
275 what?
What?
Page 275 what number?
Oh, sorry, number 118.
Oh, okay.
All right. So for this, you could go with just the trend, the electronegativity trend, which says that, the top right is the most electronegative, with fluorine being the most. And, as you go down and away, it's less. So let's start with just that. Or you could look at your table that actually has specific numbers on it, and that is on page. Hang on, I'll get there eventually. 265. So let's go ahead and do that, where you are actually using the table and tell me which one, what the numbers are, and which one is more electronegative based on their numbers. So start with carbon and hydrogen. Which one is more electronegative?
C.
Carbon is correct.
Okay, I'm confused because. Can you explain that?
Okay, the higher the number, the more electronegative it is. So between carbon and hydrogen, carbon is more electronegative because it's a 2.55, and hydrogen is only a 2.2.
Okay.
All right, so what I'm going to do now is I actually want you, are you going to add these numbers or subtract these numbers to find out if it's polar or ionic or covalent or mostly subtract them? So go ahead and subtract them, and then tell me, look at the range on page 266, which I will give you the range. You don't have to have it memorized. I'll give you this table. So tell me whether this is mostly ionic, polar covalent, mostly covalent, or non-polar covalent.
What number? 118.
118.
The one we just did,
275.
carbon and hydrogen. We're still doing that. Between carbon and hydrogen, when they bond, what kind of bond will they make?
Mostly covalent.
Mostly covalent. Because notice when you subtract those numbers, when you go 2.55 minus 2.2, you end up with 0.35, right? 0.35 on this scale, the difference scale is less than 0.4. So if it's less than 0.4, it's mostly covalent. Everyone good?
Yes.
Mm-hmm.
All right, so I want you to do the same thing with carbon and nitrogen. Tell me what kind of bond it would make. Carbon and nitrogen. Joel, you gotta stop playing right by me. He keeps crawling up.
Hi, Joel. Hi.
Hey, buddy.
Say hi. Now say bye. There's a table next to me with a printer on it, and he's literally crawling between the printer and me. It's like this big of a space. That's all. And he's crawling up there and trying to squish himself right by me. I guess that's love. He wants to be by me. All right, so you guys are doing carbon and nitrogen, right?
Yes.
I had
That
to-
was
Yeah,
polar covalent.
I still have to find the answer. Hang on.
Wait, what's
3.55. So you
got-
carbon and nitrogen. So when you subtract 3.04 minus 2.55, I got 0.49, right?
Yes.
Oh, it's mostly covalent.
That would be mostly covalent, right?
Nope.
Oh.
Less than 0.4 is mostly
Oh.
covalent. This is between, because look, 0.49 is between 0.4 and 1.7, right?
Oh, polar covalent.
Yeah.
Okay.
Do you see how it's between that range?
Yes.
Mm-hmm.
Okay. So that's why it's polar covalent. Now let's check carbon and sulfur. All right, carbon and sulfur.
That would be
Non-polar.
Shoot. It would be mostly ionic.
No, it's not greater than 1.7.
It's mostly covalent. Sorry.
Mostly
My bad.
covalent. Yes, mostly covalent is correct because it's only a difference of 0.03. Now it's not the same as being 0. That's why it's mostly covalent and not non-polar. Does that make sense?
Mm-hmm.
All right, so now let's do the last one, C and oxygen, carbon and oxygen. All right, and this one makes sense as well.
Mostly covalent.
Mostly covalent. No, it's
What?
All
Yeah,
not-
it's greater than 0.4.
right. Look, the number has to be less than 0.4. I think you're reading it differently.
Oh.
This is saying if you become greater than that, you're going to be in the range where you're polar. I don't know if they drew the signs right or if we're just reading them wrong, but
I was reading them wrong. I'm sorry.
Okay.
My brain was interpreting it as greater than.
why don't you practice doing this? Actually write it out instead, like when you think about this, write them all as ranges. 0, and then write the ranges 0.01 to 0.4. Let me write it down. Hang on. I'm going to type it. All right, so the first one I would consider as just, 0. Then the second range, my head would think of it as from this to this. If it's in that range, it'll be mostly covalent. Then notice how the next one is in a range already. It's from 0.4 to 1.7. So if it's any number in between those two, it will be polar. And then you can think of anything that's bigger than that, anything that's 1.7 or higher. So you could go 1.7 to infinity. I don't know how to write infinity. I'm just going to pretend because, why not? Anything from that range, that's going to be mostly ionic.
So, C, carbon and oxygen will all become covalent, right?
Carbon and oxygen is 0.89 when you subtract them, which is in that range of 0.4 to 1.7. So it's polar covalent. Everyone good?
Yes.
That's how I'm going to ask you those. I'm going to give you the range. You have to subtract the values. You have to show me which one of these 4 things it is. Okay? All right. I think that really the rest of the stuff that we're going to talk about is going to be more terms based because we've already covered, like I said on your test, you have multiple choice and some modified true false, which you'll have to actually write on the paper, the modified true false. I didn't leave a space for that, so you just have to actually put it in yourself, like write the numbers down and write the word that'll make it true. If it's true already, just ignore it. And then you have a section where you're naming and where you're writing formulas and where you're drawing the structures telling the shape of the angle. I think that we are good, actually. You'll just have to brush up on those terms on your own. Does that sound okay?
Yeah.
All right, I gotta go because the kids I babysit are here. Y'all have a great day.
You
I'll
too.
see you on Thursday for our lab.
Yep.
Very much.
Okay.
Bye, guys.
Bye.
So, later.
Whoa! Somebody